Okay, so the last bit of the difference of two squares, we're just going to do a quick part on recognizing less common squares or less obvious ones. So the two examples that we have here, in example 1, we have y to the power of 10 and f to the power of 8. And what the important thing to remember with recognizing these is that as long as your exponent is even, it is a square. Okay. So in this case, both of these are squares. They don't have coefficients, though, bear in mind. And if it had a coefficient, that coefficient would have to be a square coefficient as well. But in this case, because we don't have coefficients, or they're just one, one is obviously a square. So these two are both squares. So if we just do a quick reminder of rules of exponents, y to the power of a times y to the power of b equals y to the power of a plus b. And another one that will just y to the power of a all raised to the power of b is equal to y to the power of ab. So quick reminder of two of the exponent rules there. So when we're square rooting, if we look at square rooting y to the power of 10, we're looking to find something, that power of a, that when we square it, we get y to the power of 10. So that's the first one that we're looking at here. Okay, this one. Okay, we want something squared equals y to the power of 10. So going back to this rule here, we know that those two, a and 2, need to multiply to make 10. So that tells us that our square root of y to the power of 10 is y to the power of 5. Quick way is that you just need to half it, okay? But the reasoning why is because of those rules of exponents. Okay? That means the square root of f to the power of 8 is going to be f to the power of 4. So straight away, we can, once we remember those important things, we can quite quickly factorize using the difference of two squares. So y to the power of 5 is our first square root, and f to the power of 4, our second one. That has not worked. Okay. So a quick recap of some exponent rules just helps us recognize that those there are squares. Okay. Second example. Not immediately, obviously, a difference of two squares, but what is that one really important thing? Common factor. Okay. So first of all, you're going to factorize by taking out the highest common factor. Okay. So if we look at that closely, we have exponents of 4 and 6. So if we go back here, do we have even exponents? Yes. Do we also have square coefficients? Yep, that 4 and that 1 are square coefficients. So again, we can do a similar thing here. Okay, halving that exponent of y to square root it, halving that exponent of 6 to square root it, and then square rooting our 4. Okay. Get our contents of our brackets for the difference of two squares. Okay. 1 plus bracket and 1 minus bracket. Doesn't matter which way around. Can't have that bracket like that. Okay. So again, that common factor keeps coming up. Really, really important. So I'd have a go at a couple of these ones that are a bit more unusual to recognize. Students often forget to look for them later down the line. So come back to this as many times as you like, but have a go at those few there. And come back for the answers. Answers should be those there for you. Let me know if you have any questions.